Okay, so this is my smart home automation project that I have been working for, and basically we have Raspberry Pi in, let's say, our living room. It's connected to a radio frequency module, and it's communicating to all of our peripheral devices. But how is it communicating actually? As you can see, we have here an Arduino, and this is a small LED button, and this is the radio frequency controller. Basically, this Arduino is plugged in to the adapter, and it's communicating to a Raspberry Pi like small PC. Basically, that gives us a whole lot of advantages, mainly to control and see the status of our devices via the web, or just control them. Like it can be that simple. But here I run into a couple of issues. Basically, main issue here is I haven't optimized the session. I mean, these kind of projects have been like seen before, and I'll just cut here for now. As you can see, here's the off button, and the LED is off. Now, I'm hoping that I've turned on the Raspberry Pi communicator, and when I turn this on, I can check here in the database that I have the device status. Yeah, device status is 1. So if I turn back around, I will see that the LED is turned on, because the Raspberry Pi got the information from my session, and that my session is authorized to do a task like that. So basically, here we have a whole session management that enables me to do things like that, like to turn the button on and off. I mean, not anyone can be and should be enabled to do such thing, just the people that are home members. So basically, you do a registration, and when you do a registration, here we check if someone is authorized to do such a task. Now basically we have here a couple of things. One thing is that whenever we refresh this page, the Raspberry Pi serving as a host will check the database, and we'll check the existing status of all home devices and will show them. So for now, when we logged in, it was off because the LED was off. And also, if I press here off, then again we should be able to see the change here. And yeah, we have device status 0. And when we turn back around, oh loady load, the LED truly is off. Now let's just say that a simple user clicks this LED, and when he clicks it, he turns it on. Now should that mean that someone, a home member that is wanting to communicate and to see the status of his device, when he refreshes the page, and yeah, now this will take some time because I haven't optimized as I said so, but when he refreshes the page, he will see that the device is on, and basically that should be that. But it's no magic. Basically, I've turned here the SSH connection, and as you can see, this is the C++ that I have been working on. And when we look at it like a bit, just a second, I refresh the page, and as you can see, it's on because the device is turned on. So we have proven that that works. Now, why does it work? Well, let's scroll back around. Now here's the status 1. that status 1 we got, and we got here 0, and we got the package from our Raspberry Pi. Now it says post initiation processing, we have packet red, device ID, device status, marking house change. Now the change has happened in the house because the Arduino basically changed the status, and it made a different status than one written in the database. Now changes happened, commit failed, trying again, and after that the commit succeeded. So basically we have successfully written the change in the database. Now since we have successfully written the change in the database, the user that has been refreshing the page basically got the updated status of the given LED. Now, no magic again, we press it and it will indeed turn off, as you can see. Okay, so here we have again, now we will see the updated status of those ones, and yeah, here's some zeros. Now basically we have here a change. Got results, dev ID, device status, got a change on the web, sending to update device. Now basically the thing that we got a packet from the web, and that we are wanting to change the device status doesn't mean jack shit. Basically, if you just change that in the database, that doesn't mean nothing. I mean, if I've written things in the database, that doesn't mean that I'm controlling my devices, because devices are hardware and they're like, you can touch them, you can they're electrical components. Basically you need something like Arduino to communicate with those devices, sending them the direct current signals and stuff like that. So basically sending to update device. Now here's the device, here's the device, send to update device 0. Yeah, the device 0 is the LED, and the node ID is 1. The node ID is basically the ID of the radio that we are connecting with status 0. So basically this is the status that should be updated with. And yeah, so basically that's that. You can check the blog. That I will be writing the guide on how I have done this. And basically I will try to keep it simple and in pieces, and I hope that you enjoyed this. Basically there's a long way ahead to finish this project, but I can see the light at the end of the tunnel. I mean, it's quite possible that you can control your home from the web, and if you do it yourself, it will probably be less than 500 bucks. Basically, I have rendered this proof of concept for around 40 bucks, and I'm planning to automate quite a large portion of my house with around 200 bucks that I've invested. And so far it's going really good. Yeah. So hope you liked it. If you have any questions, you can post it in the comments. And yeah, if you like the video, press the like button, subscribe if you want. I will maybe do a couple more if you want to see the programming behind it, but basically the bigger portion will be on my blog post. Yeah, so see you later. Goodbye.